Welcome to cryptography session. Today I will give an introduction about Fermat's theorem, Euler's theorem, and few problems related to these theorems. Let us take Fermat's theorem. It is used to apply for finding the remainder values of mod, and we can use it to apply this Fermat theorem only for mod value as prime number. So if you take the right side of mod, it is represented as a variable p. So p should be a prime number means only we can able to use or apply this Fermat theorem. And what are all the conditions for implementing Fermat theorem means the right side mod value should be a prime number. A value, that means the remainder value should be a positive number, and that number should not be divisible by p. Then only we can able to apply these notations. So Fermat theorem first version is a power p minus 1 mod p, that should be equivalent to 1. Otherwise we can able to apply this mod p to at right side. So the theorem may also able to write like a power p minus 1 is equivalent to 1 mod p. So this is version 1. So if you take this relation between a and b, those a and p should be relatively prime. So here p should be a prime number, and if you calculate a GCD of a comma p, that should be equivalent to 1. So this is the conditions for applying Fermat theorem. And the version 2 is the modified one of version 1. So instead of a power p minus 1, if the answer is a power p, so a power p mod p is equivalent to a. So either the answer may be from the version 1 or from the version 2. So these are all Fermat theorem. So this is the first version and second version. So the right side mod value should be a prime number. Then only we can able to apply this Fermat theorem. Let us take an example 1. 6 power 10 mod 11. So find the value for this one. So here the right side value should be taken as p. So my p value should be 11. So the general format is a power p mod p. So here a value is 6. So what are the conditions? P should be a prime number. So this condition is satisfied. A should be a positive number. That is also satisfied. A value or a p value does not be divisible one. So a value is 6. So 6 is not divided by p. That is also satisfied. And a and p are relatively prime. So if you apply GCD of a comma p, the answer is 1. So these 4 conditions are satisfied. Then we try to find the power value. So here it is like p minus 1. So what is the rule 1? So if we apply version 1 is a power p minus 1 mod p is equivalent to 1. So the number for a is 6. So p minus 1 is 10. So 6 power 10 mod 11 is, for applying rule, the answer is 1. So the answer for the first one is 1. Let us take the second example, 3 power 12 mod 11. So here a is 3, p is 11. So p is a prime number, a is a positive number, a is not divisible by p. And if you take a GCD of a comma p, the answer is 1. So all these conditions are satisfied, but the power value is not like p minus 1. Either the power value should be p minus 1 or p, but the answer is p plus 1. So 3 power 12, it can be rewritten as 3 power 11 into 3 power 1. And if you apply the mod calculations, a into b mod 11 can be rewritten as a mod 11 into b mod 11. So for applying those rules, the answer will be rewritten as 3 power 11 mod 11 into 3 mod 11. This is like version 2. So the version 2 is, if the value is a power p mod p, that should be equivalent to a. So by applying version 2 of Fermat theorem, the answer for the first mod operation is a. So here the answer of a is 3. And 3 mod 11 is 3. 3 into 3, 9. So it is also less than 11. So the answer for the second problem is 9. Sometimes the power value may be rewritten as a negative number. So negative number means a multiplicative inverse. So if the answer for power value is -1, that is the multiplicative inverse of given value. So the rule for multiplicative inverse of a given number in mod p is a power -1 mod p can be rewritten as a power p minus 2 mod p. So either a minus 1, instead of a minus 1, we may able to apply a power p minus 2. So let us take the first value, that is LHS portion, a power -1 mod p. I want to calculate the value. So if you take 8 inverse, 8 inverse is the multiplicative inverse of 8. So if you multiply a number and its multiplicative inverse, the answer should be 1. Like that, I multiply a value at both end, both LHS part and RHS part. So the left side part is rewritten as a into a power -1 mod p. The right side portion is a into a power p minus 2 mod p. Here the answer is a into a power -1. It is a multiplicative inverse of two numbers. So the answer is 1 at LHS part. If you consider a right HS part, it is a power 1 into a power p minus 2. So we may able to sum up the power value. So p minus 2 plus 1 is p minus 1. By applying version 1 of Fermat theorem, a power p minus 1 mod p is 1. So if you want to find out the inverse of a particular value, we may able to apply these concepts. So for example, 8 power -1 mod 7. So what is the answer for this one? I want to calculate the answer for this one. So first we should apply 8 into 8 inverse mod 7. I don't know the value of 8 inverse, so apply x. So 8 into x mod 7, the number should be equivalent to 1. So first you substitute x is 1. If you substitute x is 1, 8 into 1 is 8, 8 mod 7 is 1. So the answer is 1. So 8 inverse mod 7 is 1, which means that 1 is the multiplicative inverse of 8 in mod 7. So in this way, the power value is, if the power value is negative, we may also apply these concepts. So this is another example, 5 inverse mod 23, which means that we should find out the multiplicative inverse of 5 at mod 23. So the answer is 14. So 5 14s are 70. So 70 mod 23, like that we may able to calculate. So 23 into 3 is 69. So 70 mod 69 23 is, remainder is 1. So the answer is 14. Like that we may able to calculate the answer for 60 inverse and 22 inverse. So I will give the answers discussions of third and fourth one is up to you. You just go through it and calculate the answer, whether these two answers are correct for the third and fourth problem. Let us discuss the Euler's theorem in next session. Thank you.